Okay, hello. This is work rate problems notes. I'm hoping that the audio has been fixed. I've gone through a couple of fixes, and I think that hopefully the audio problems that we've had are solved. So uh, thank you for the feedback on that. This is a formula, rate times time equals distance, that we use quite a bit this year, and we've used it leading into our science formulas and working with IFSMU. And this is another type of problem, but based in our chapter with rational numbers. So we think back to, our I for if SMU. If we identify the rate is 20 miles an hour, time is t hours. I don't know distance is number of miles because they all have to uh, match or add up. If I can, how's that? How's that sound? Okay. So rate times time equals distance. Whatever that says. All right, 20 times t equals 150, and we'd solve this, divide by 20 algebraically. And this is kind of what we've done so far. And then we get 7.5, and then so this would be the F. Here's the I step, F, S, M. You get 7.5, and the U would be 7.5, and then we go back and say that it's hours. So it's hours, or whatever that says. Okay. And then we could also say that rate times time equals, instead of distance, amount of work. And this kind of implies if it's not a, the rate isn't dealing with distance, it's not a distance rate. It could be amount of work or amount of money, right? If I get paid $12 per hour, so that rate times the number of hours would give me a amount of, in that case, money. But we're going to talk about work rate problems today. And so this is saying that maybe my rate, again, is comparing two measurements. My rate of, that word is grading. So if I can grade one class of tests in 3 hours, then my rate of grading is, well, if I can grade one test in 3 hours, then my rate per hour is 1/3 of a class per hour. And so you see how if it takes me a total 3 hours to complete the job, the individual rate per hour would be kind of the reciprocal of that, right? 1/3 of the class per hour. If I can grade one class in 3 hours, my per hour or rate is 1/3. All right. So now we've got an example here. Mary and Megan are next door neighbors with identical sized garages. Well, that's nice. Mary can clean her garage in 3 hours. Megan can clean her garage in 4 hours. Now, again, this is the total amount of time that it takes to complete the job. So Mary in 3 hours, and let's do Megan in a different color. That sounds like fun. 4 hours. So Mary's rate then, right, is going to be 1/3 of a garage per hour. All right, so that's Mary's rate. All right, Megan's rate. Oh, we're supposed to do her in green, sorry. Megan's rate is, if she can complete the whole job in 4 hours, it would be 1/4 of a garage per hour. Now, obviously, key is that they have identical sized garages here. Okay, so now the question is, how long will it take the two girls working together? So together, we're going to have to add their amount of work done, right? And their amount of work is their individual rate times time. The time is, we don't know, so that's going to be t hours. And the amount of work done is going to be one whole garage. So how long would it take them to clean? Oh, both garages. I'm sorry. So that's not 1. That's 2, Mr. Bossert. 1 plus 1 is 2. It is true. All right, so 2 garages. All right. So that's how that's my identify stage, my I in IFSMU. All right, my F is going to be my formula. This is going to be Mary's rate times time plus Megan's rate times time is going to equal the total job, right? However much she does plus however much she does is got to equal 2 garages. All right, so Mary's rate times time is going to be 1/3 T. Megan's rate times time is going to be 1/4 T. And that's got to equal 2. And this is the basic setup of this type of problem. Now, it looks a lot like what we've done now here in our chapter 4 and 5 because we've got fractional rational equation. So what I want to do is I'm going to I'm going to multiply through by the LCM of, in this case, 12, right? 12. All right, so if I multiply everything by 12, now I've got 4t plus 3t equals 24. And then go ahead and solve. T equals 24/7, which is 3. And for Luke, we'll say it's 0.428571 repeating hours. I know that doesn't make any sense because of the long drawn out decimal. So we'll make it 3 3/7 hours. Or if you want to, take your multiply this by 60, that would give you a number of minutes. But you could say 3 3/7 hours. That sounds a little less than 3.5 hours for them to clean both garages together. Okay. But again, the whole deal was making sure you got the rates correct, and they're working together, so it's rate times time equals distance. All right, Dave can run a mile in 6 minutes. Larry can run one in 8 minutes, and Jeff in 12. If the 3 guys complete a relay where everyone runs the same amount, how long will it take their team to complete the mile? So, again, their rates are going to be in miles per minute. We got minutes and we got miles. All right, so those are our things. So Dave is going to be if he can run a mile in 6 minutes, his rate is 1/6 of a mile per minute. Right? Jeff is going to be 1 mile in 12 minutes. He's kind of slow. Oh, I've skipped Larry. Sorry, Larry. Larry is going to be, we can run one in 8 minutes, so his is 1/8 of a mile per minute. And Jeff is 1/12 of a mile per minute. And if we add each of their rate times, right? So this is Dave's rate times time plus Larry's, I forgot Larry again, rate time plus Jeff's rate times time. If we add, this would be each of their distance that they run. If we add the 3 up, it's got to equal 1 mile. Or we could say that each of them's got to run a third, right? So let's change that up. Is that right? So each of them's got to run a third, and then we've got to add it up. So Dave's rate times time, and his is going to equal 1/3. All right, so if we do 1/6 T equals 1/3. All right, his time is going to be 2 minutes. So Dave is going to run in 2 minutes. Larry is going to run 1/8 T. So Larry is going to run his in 8/3 or 2 2/3 minutes. And good old Jeff is 1/12 T is equal to his 1/3 of a mile. So his time is going to be 4 minutes. So if I add these up, it looks like it's going to be 8 2/3 minutes, or 8 minutes and 40 seconds. In which case you'd say, well, then take Jeff out of it because he's just slowing everybody down. Either have Dave run the whole thing, or they run, well, maybe they have to do 3 guys. I don't know. Okay, and then the last one I want to do is talk about Paul can split a cord in 12 hours. A cord of wood is a bunch of wood, and you split it up into smaller sections with an axe. His father can split a cord of wood in 4 hours. How long do Paul and his father take to split a cord of wood if they work together? So again, now they're working together. Each of their rate times time would equal the amount that they get done, and that's going to be added together to equal 1 whole. I'm going to pause this. I want you to pause it, and I want you to see if you can do the full if SMU on this, and then come back and we'll get an answer here in a second. So pause it, please. All right, so hopefully that you also answered it similarly. I've got over here that Paul's rate is going to be 1/12 of a cord per hour, and his father is going to be 1/4 of a cord per hour. Again, they can complete the whole job in this time. Per and 1, right, would be 1/12 of that, or the reciprocal of that. The time I have listed we don't know, so that's T hours, and then the amount is 1 cord of wood. So there's my equation. This is Paul's rate times time, so that's his amount that he can get done. This is his father's amount that he can get done, and together they've got to equal 1 whole cord. I multiplied through by 12 because that was the LCM. It gave me 4T equals 12, or T equals 3 hours. So again, we've got multiple people or things working together. We're going to add their rate times together to equal a total amount that needs to get accomplished. And that's how we're going to go ahead and solve these problems. All right, thank you. Namaste.